Welcome. So this question says a 2 kilogram ball is attached to a branch by a rope that is 4 meters long. The ball is swung in an arc forming a pendulum. The speed of the ball at its lowest point is 7 meters per second. What is the tension in the rope at its lowest point in the swing? So looking over at this picture at the side, what we have is this thing is swinging backwards and forwards and backwards and forwards. And the question refers you to when it's at its lowest point. So we need to look at this lowest point. So let's look, and we have, first of all, it's 2 kilograms. And then we have a tension force pulling the ball upwards. And we have a weight pulling on the ball. And the ball is clearly not in equilibrium. It's going in a circle, so there must be a centripetal acceleration. And so we simply apply Newton's second law. We say find T using the sum of the forces vertically equals ma vertically. So we say that a sum of the forces vertically equals ma vertical, which in this case is equal to mac, because it's a centripetal acceleration, which equals m times v squared over r, because that's what centripetal acceleration is. So now I look and I say, oh, plus t, because that's pointing upwards, added to minus 20, because that's pointing downwards, is equal to the mass, which is 2, times the speed, which is 7, got to square that, over the radius, which is 4. So I say, well, plus t added to minus 20 is equal to a half of 7 7s are 49, a half of 49 is 24.5. So that means that t is equal to 24.5 plus 20, which equals 44.5 newtons. And there we have it. It's there. Now, when I give this question, I notice that people sometimes only get half the answer. They'll either tell me the weight and ignore the effect of the circular motion, or they'll tell me the centripetal force in effect, the mass times the centripetal acceleration, and they'll ignore the weight. And I think that's because they're thinking about this piecemeal. They're thinking about, oh yeah, we have a weight issue and not getting the circular motion, or they're saying, yeah, there's a circular motion issue and not getting the weight. And what I do is initially I focus on getting a good diagram with all the information. And then I let the Newton's laws take charge. I recognize it's a non-equilibrium situation, so I'm using Newton's second law. I recognize that my acceleration is known, or at least I know how to get it because it's a centripetal acceleration. And then I let the problem unfold. I think of this as thinking in complete sentences. This is a complete sentence. Whereas if I was to say, well, weights involved, so that's mg, and then centripetal stuff's involved, so that's, well, mv squared over r, and then do I add them together or do I subtract one from the other? Notice that 4.5 is there, and also 20 is there. So if you just have the weight, you've got an answer. If you only have the centripetal acceleration, you only have the centripetal, you've got an answer. If you subtract the two of them, you've got an answer. If you add the two of them, you've got an answer. I'm trying to ring all the changes here, all the possibilities. And as I say, the biggest mistake I see is people, they're trying to do so much in their head and then construct the answer whereas I try to construct a visualization and I let the thing just unfold. I think that's a really valuable approach. So there we have it.